Has anybody ever watched one of my videos?
Every time.
Oh, yeah, every time. You like the incredible quality of the videos? They're just fantastic.
I don't think the stuff I don't understand is what's that.
Well, you can't be told too many times. The little subheading under this probability gizmo gadget is, I think, probability of, well, it says the multiplication rule. Which hopefully makes you think about something there. But let me ask you this question. Let's say you roll a dice, and I asked you what the probability of rolling a 6 is. What is the probability of rolling a 6 on a dice? Remember, probability simply is how many total outcomes are there? There's 6 sides to a dice. How many of them are 6s? 1. So the probability of rolling a 6 is 1/6. What's the probability of then rolling a dice and getting a 3? Rev? Yeah, it's the same thing because there's still 6 sides and there's still only one thing. But if I ask you, and here's the question of the day, what's the prob of rolling a 6 and then a 3? You would say what? Well, if there are two different things, maybe you can guess where this is going based on the little note up there. When you have two different probabilities that you want to happen, you can find the probability of both happening, which would look like this. The probability of a 6 and a 3 is getting the probability of the 6 and multiplying it by the probability of getting a 3. Which means, we already know our probabilities because we did it there. The probability of getting a 6 was 1/6, and the probability of getting a 3 was 1/6. So the probability of both of those happening is 1/36. 1/36. Just like the probability of you know, let's say you have a spinner that's cut into A, B, C, and D. And then just for fun, you were flipping a coin. Let's say this is George Washington. Did George come up on the coin? It's not a bad George. And I asked you, what would be the probability of spinning a D and then flipping and getting a tail? Well, the probability of both of those things happening in that order is the probability of getting a D times the probability of getting a tail. That's the multiplication rule. And when you do that, probability of spinning a D is 1 in 4, right? And the probability of getting tail is 1/2. So the probability of that is 1/8. Now, you could show this. You could make a little tree diagram, not that you would ever want to. But you could do that simply by doing this. Let's look at the two things that have to happen. You're doing your spinner. What are the outcomes of a spinner? Well, I could have spun an A, I could spin a B, I could spin a C, and I could spin a D, right? So that's what could happen on the first thing. On the second thing, off of each one of these, I could get a head or a tail. A head or a tail. So this is going to give me all the possible combinations. I could have an A and a head. I could get an A and a tail. I could get a B and a head, and a B and a tail. I could get a C and a head, and a C and a tail, and a D and a head, and a D and a tail. How many different combinations are there? 1, 2, 3, 4, 5, 6, 7, 8. That's the bottom of an 8. And how many of those are the one I want, which was a DT? That was this one right here. There's only one DT out of those 8, so Is that exciting or what? Now, the other thing you have to watch out for is, and because we play a lot of games with dice, Yahtzee or those gambling games, which I don't play because I always lose, Aiden, so it's just the way it is. If you roll 2 dice, which we do for a lot of board games, what, like Monopoly, you roll 2 dice. What else do you roll 2 dice?
Clue.
Clue? Do you do for Clue? I don't know, whatever, yeah, you do to move your guys, and Clue, you do, okay. If they ask you what the probability of like rolling a 7 is, oof. The probability when you have 2 dice is, there are a whole bunch of different combinations that'll give you a 7, right? You could roll a 1 and a 6, you could roll a 2 and a 5, you could roll a 3 and a 4, a 4 and a 3, and a blah, 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 blah. So in order to help you with that, here's where the helpful handout comes. Because they ask you a lot of times to do this. And you can either draw your own table, but I don't want you to do that because that is just, gets to be kind of goofy. So you can stick this in your notes as a reference, as a little handout, because it will ask you a lot of times about rolling 2 dice. Now see if we can get the gist of how this works. Let me see if I can find it on my thing. Where do you suppose I would have tucked that away? Anybody? Under probability. Under math. Under probability. And what do you think I called it? I probably called it a dice thing. Combos when you roll a pair of dice. Or dice table, which one?
Dice table.
I don't know. Yeah, see, that was the wrong one. It's the same thing. Well, I'll tell you what, let me pull this one up, because it's the same thing you have, but you can see it. I think this might give it to you a little bit better. I mean, you'll be able to see where the table comes from. Sorry, don't worry. River, I'm a trained professional here. Just not trained on this board. Why do you keep doing it? Alright, there we go. Can you see? On that one that you have, you don't have the little dicey looking things. But you can see this. This is all the combinations when you roll 2 dice at the same time. Okay? Because when you roll 2 dice, you could roll a 1 and a 1, and that gives you a 2. You could roll a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and 5, 1 and a 6, or all those sort of things. Just know this, and you probably want to write this down here. When you roll 2 dice, you really have 36 outcomes. There are 36 different possibilities there. You don't get 36 different numbers, but there's 36 different ways you can roll them. And, dice games or whatever based on a probability here, the probability of rolling a 7 is the greatest probability of rolling anything. Why? Because there are 1, 2, 3, 4, 5. There are 6 different ways you can roll a 7 when you roll 2 dice. So 6 out of 36 means 1 out of 6 times you should roll a 7. Now what's the smallest probability is either to roll a 12, which there's only one combination that gives you a 12, which is a 6 and a 6. So that's a 1 and a 36. And the probability of rolling a 2 is the other small one, because there's only one way to get a 2, which is a 1 and a 1. Everything else, the probability increases a little bit as you go. Let's see, what does the book ask us? Here's one. 2 number cubes are rolled. How many possible outcomes are there for which the first roll is even and the second roll is even? Let me ask you that question. How many outcomes are there with the first roll is even and the second roll is even? So if you look at your little table here, you can do this as roll 1. How many outcomes are there where the first roll is even? All of these are first roll evens. All of these are first roll evens. And all of those are first roll evens, right? And the second roll is even as well. All of these, we've already got those there, so all of these are second roll evens. So if you're looking at the possible combinations there, how many of the 36 would you get where the first row even and the second row even? Oh wait, is that right? An even outcome, a 2, 4, 6 can occur 3 ways. I don't understand the question. You understand the question? What's that? But all of these aren't even numbers, aren't they? Let's skip that question. I'm gonna move on to a different one. Is there another dice question? I want a dice question. Somebody find a dice question. Yes, practice C. 2 number cubes are rolled. What's the probability of rolling a number greater than 4 on each number cube? You know, actually, you don't always have to look at this thing because this might confuse you if you look at it. For practice letter C, what does practice letter C ask you? You want to write down the probability. Practice C says the probability of rolling a number greater than 4 on each cube. So probability greater than 4, and then you're going to do it again, probability greater than 4. So how many numbers, if you're rolling a cube, how many numbers are greater than 4? 2. 2 out of the 6, right? How many numbers are greater than 4 over there? 2 out of the 6. So your probability is those two multiplied together, which is, well, they're both 1/3. I guess you would get 1/9 for that. That's probably what we should have done for this, rather than me circling all those numbers, because that just probably looked it, didn't it, Reverend? Does that make sense? Any small yet? How about letter D? One more question. If a coin is flipped 4 times, what's the probability it will be heads all 4 times? What should you write on your paper, you ask? You are looking for the probability of flipping a head. Well, actually, it would look like this. A head 4 times in a row. That is your probability. Which means it is all those probabilities all multiplied together. Probability of head, probability of head, probability of head, probability of head. Which would be what? Probability of getting a head is a half every time. And what is it if you multiply a half times a half times a half? Please don't tell me 1/8. Yeah, 2 times 2 is 4 times 2 is 8 times 2 is 16. If you took 4 coins and put them in your hand and you flipped them 1 out of 16 times, they should all end up being heads. Will it happen? Sometimes. Is it guaranteed to happen?